Okay, here we go. I'm going to try to do this quickly. So this is a PERT chart, and it starts at M0, goes to M6. That's the start, that's the end. The activities that are contained here are A, B, C, D, E, F, G, and H. I have those listed here as tasks or activities. The times for each of those activities, A is 3, B is 5. That would be the time it takes to complete the activity. Those numbers are right here. That's how you would complete those two columns on your chart. The second column here is for precedence relations. You're going to put the tasks that occur immediately before the given task in that row for precedence relation. And the way you determine that is by looking at the milestone that the task comes out or emanates from. In this case, A emanates from milestone 0. There is no task that goes in there, so there is no precedent relation for A. Same for B. B comes out of milestone 0. There is no task going into B, so there is no precedent relation for B. Up here for task C comes out of milestone 1. A is the only task that enters milestone 1. That would be the precedent relation for C. For D, comes out of milestone 1 as well, which means A is its precedence relation. For E, comes out of milestone 2. The only one going in there is B. For F, the only one going into milestone 3 is C. For G, G comes out of milestone 4. There are two tasks entering there, D and E, so I'll count those both as precedence relation. And then finally, for H, there are two activities that go in there, F and G. All right, that's the precedent relation column. Now, in order to fill in the slack time column, what you need to do is you need to identify the critical path, which is the longest path through the network. In this case, we have three paths through: M0, M1, M3, M5, M6, M0, M1, M4, M5, M6, M0, M2, M4, M5, M6. And I have the activities for each of those listed here, and if you add up the time to complete each of those tasks along this path, the total time to cross it would be 24 units. For the second one, it's 30 units, and then for the last one, it's 29 units. The longest of those three is the critical path. The critical path then would be the one that goes here from A down through D to G, and then finally H. Those activities then are the activities along the critical path. The length of time, the shortest length of time to complete the entire job is the length of the critical path, which is a little counterintuitive, but think about it a little bit. The quickest way to get through this is actually the longest, because you have to do all these tasks, and so you can't get through this any faster than going along that critical path. All right, so that's 30. Now, in terms of the slack times, anything that's on the critical path has a slack time of 0. So A has a slack time of 0, D has a slack time of 0, G has a slack time of 0, and H has a slack time of 0. To find the slack times for B and E, what I'm going to do is I'm going to compare the time along the critical path from milestone 0, 1 to 4 with the time along this alternative path from milestone 0, 2 to 4. Along the critical path, it takes 3 plus 8 or 11 units of time to go from milestone 0 to 4. Along this alternative path, it takes 5 plus 5 or 10 units of time. And the slack time is the difference between that. 11 minus 10 would be 1. So for B and E, we're going to assign both of those a slack time of 1. Right? You couldn't use 1 extra unit of time for both of them, but theoretically, I could take 6 units here, and 5 would put me here at 11 units, which is equal to the length along the critical path. Or no extra time there and 1 extra unit there, and that would give me a total of 11 as well. All right, you could split it half and half, etc. To get the slack time for C and F, I'm going to count the time from M1 through M4 to M5 along the critical path, which is 8 and 9 is 17 units. Along this alternative path, 6 and 5 is 11 units. The difference between 17 and 11 is 6, and I'm going to assign to C and F 6 units of slack time. And that completes the table.